Hello and Assalamualaikum. Today I would like to present our project named River Trash Barrier. This product was designed by High Flash Company, which is our company. Before that, I would like to introduce myself. So my name is Ahmad Farouk bin Ahmad Isyamuddin and I'm from BMMV Astro Scope 1. And my metric number V091910325. So in this project, I am the chief of this project. First thing first, as you can see, this is our company logo and our company name, which is called High Flash Company. So every company has their own company code. Our company code was waste management. Various operations and also products that have been produced to succeed in the business of this company, such as river cleaning operation. Besides that, our company has produced a product called River Trash Barrier. Every company has their own vision and mission. For the H Company's goal is to extract as much plastic and floating waste from rivers as possible. Want to achieve this through 4 pathways. The first one is clean up the plastic soap in rivers using our product River Trash Barrier. The second one, increase awareness of our product River Trash Barrier as site for public tours and educational program. The third one, measure and monitor the amount of plastic in the rivers to help develop better policy and action. The last one is help build a circular plastic chain by recovering and recycling waste from river vision. So as we can see here, this is our organization chart. So you can see that is me as a project leader. We can hear that a good leader makes a good follower. So in our organization, we had a CAD analysis engineer, we have analysis engineer, we have costing, procurement engineers, and the last one we have manufacturing and assembly engineers.
Hello, my name is Dara Esman. I am the CAD and Analysis Engineer. So now I'm going to explain about Chapter 1, which is the introduction and the background theory. So for the introduction, as we all know, plastic waste accumulates in the ocean and river at alarming rates. So the goal of our project is to develop a technology that will aid the removal of plastic and floating waste from river before it reaches the sea. So next is a problem statement. So river play a crucial role in human life. Although there are a lot of mechanisms are created to reduce and control the water pollution, but still the mechanism does not satisfy the requirement and limited in scope. So most of the rubbish barrier are smaller in size. So when the barrier is small, the barrier need to clean more often. So the objective of our project, there are three objectives. The first one is to create a trash barrier which attach it to the riverbank in urban areas to collect the floating waste. Second, to design products that have aspects such as safety, aquatic friendly, and low maintenance. And lastly, the durability of the product should last longer than the existing product in the market. So now I'm gonna explain about the chapter 2. So as you can see from the slide, this is our flowchart. So we start by defining a problem, and then we generate idea from the problem. Then next we done some literature study, and we done some conceptual design. So there are three design concept that we done, and we pick one. We also did the final design by using SolidWorks and analyze it. Next is benchmarking. So there are a few factors that we done, which is the cost, size of barrier, maintenance, durability, aquatic friendly, and manpower. So we compare our product with other product. You can see the comparison on the slide. Next is design concept sketching. So there are three design concept that we done from this slide. You can see the first design concept. Next slide, you can see the second and the that design concept. So for the design selection, we're using the PERC method analysis. So there are a few selection criteria for the analysis. So the first one is low cost, durability, aquatic friendly, size of the barrier, the effectiveness of the barrier, low maintenance, usage term, and movement of barrier. So we calculate the net score and rank each of the design. Next is the final design. So as you can see, the one on the left is the design that we come up with using the SolidWorks. The design on the right side is the design that we come out by using SolidWorks Visualize. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Naafkaina binti Zahra. My matrix number is P09110062. I'm from BMMV 201. As a costing and procurement engineer, I will explain in chapter 3, which is product development. Okay, so first of all, we have a drawing part by part. First, we have a base on the top of cage, and then we have a cylinder floater to support the cage to float on the surface of water. And next, we have a wall attachment to support the cage to stick to the river banks, and then we have a cage handle, slide lock A, and then slide, bolt M10, slide lock B, and then we have a washer, nut M15, and the last one we have bolt M15. Okay, next we proceed with working principle. The cylinder floater has been designed to float on the surface of water, and it is made out of highly durable polyethylene HDPE. This product will be installed to the river banks according to the river flow to trap the trash easily. This project fully uses renewable energy. Maintenance schedule has been prepared in order to address the issue of the trash accumulating in the barrier overflowing. And then with the help of adjustable wall attachment at here, these products are able to adjust it high to facilitate the maintenance and cleaning process. The barrier has been designed to be simply removed and reinstalled. Cost of calculation. Okay, so first we have 1 pieces of galvanized steel plate for base cost 109 ringgit 81 cent. Next we have 70 ringgit for 2 pieces of polyethylene high density cylinder floater. Then 77 ringgit 83 for 1 pair of carbon steel sheet wall attachment. Next 13 ringgit 24 cent for 4 pieces of slide lock A chrome stainless steel, and 11 ringgit for 4 pieces of slide lock B chrome stainless steel. And then we have 25 ringgit for 1 pieces of cage handle carbon steel sheet. For 1 unit cage type 316 stainless steel costs 494 ringgit 16 cent. We also have 17 ringgit 40 cent for 4 pieces of M15 bolt carbon steel, 18 ringgit 20 cent for 26 pieces of M10 bolt carbon steel, and then 4 ringgit for 4 pieces of carbon steel washer. Next 2 ringgit for 40 cent for 4 pieces of non-M50 carbon steel, and the last one is 14 ringgit 82 cent for 2 pair of slide chrome stainless steel. By the way, all these item and price quotation are obtained from shopee.com.my and alibaba.com. Then for last part, we have a process of safety. This project has been studied and tested before it is marketed and is created using a high durability of component and evaluated with 1 research and factor of safety distribution. This process involved in environmental and sustainability factor. That's all for me as a costing and procurement engineer. Thank you.
Assalamualaikum. I Nufati Zati binti Masahat. I am Engineer Analysis.
Material properties. For cage, we choose the material types 316L stainless steel. The material used by this barrier is the 316L stainless steel, which has a mass density of 8027 kg per meter cube. Stainless steel remains the stainless or does not rust because of the interaction between its alloying element and the environment. The excellent balance of properties make the 316L stainless steel is the ideal material for the other metal replacement in the application to make it long-lasting in the water. Analysis result. Okay, von Mises stress is a value that is used to determine whether a material will yield or fracture. As shown in the image, this is a view after we apply the von Mises stress to our product. After we applying, the result of the minimum stress is 1.348 Newton per meter square, and the result of the maximum stress is 1.086 the power of 7 Newton meter square. Second is the displacement. A vector is represented by the displacement. This is the view after we do the analysis result from the displacement on our project. The minimum displacement that we get is 1 the power of negative 3 mm, and the maximum is 3.247 the power of negative 1 mm. And lastly is the factor of safety. A factor of safety (FOS), also known as used interchangeable with the safety factor, is a engineering. This is the conclusion of the analysis for the safety factor. The minimum and the maximum value are 1.878 power of 1 and 2.097 the power of 8 respectively. Failure analysis, design failure mode and effect analysis. We have two items, wall attachment and cylinder floated. Okay, for the wall attachment, the potential failure mode is a sliding failure. For cylinder floated, is a floating failure. For the probability for wall attachment is C, occasional failure. For the cylinder, we choose a B, remote failure, related few failure. Severity, for wall attachment, we choose type 3, that is a minor. And to cylinder, we choose type 2, very minor. Detection, we choose a type 4. For the cylinder, choose type 5. Improvement of the product. First, follow up with buyer. Consider sending customer an email after they made a purchase. When the purchase is fresh in the mind, it is more likely to receive a review. Second, product quality. The company places a high value on product quality. Product quality can be defined as an overall or specific aggregate value of satisfaction with the product function and characteristic. And lastly is adding new features. The addition of new features broaden the scope of existing product. The addition of the benefit to product such as trash storage space, chemical, water filter, and so on. That's all from me. Thank you.
For the conclusion in our project, it can be said that all the objectives for the river trash barrier were met. The objectives are achieved through a numerous problems and issues that arise from analysis. All the problems were accounted and dealt with according to the specific methodology. The primary goal of the research is to reduce water pollution in the river in order to improve water quality. Improvement in practice and procedure will allow for more effective planning and education. The river trash barrier aids in the efficient and productive management of the ecosystem. This river has an equation-friendly system that ensures that product does not harm the environment. Okay, so that's all from our team. Thank you and see you when I see you. Bye.